Let's consider this program. Well, we'll start by looking at the first line. Here you can see A has been assigned the integer 7. On this line you can see that B has been also assigned 7, but it's 7.0, which is an example of a float in Python. If we now go on to the next line, what's happening here, we're taking the A and we're passing it to the function type, and type will return something, and this something is then printed to the screen. So let's have a look what we actually get printed, and you can see over here that what we get is this string appearing here. And the key for us at this stage is to realize that in fact what we can see here, it has the word int. Now what that is doing is telling us that A is of type int. And if you look here, you can see that in fact that's correct, because we let A be assigned 7, and 7 is an integer. If we now go on look at the next line of code, which is this one here, we're doing something similar, but on this occasion we're sending B as the parameter to the function type, and type will return something, and whatever that is will be printed. So let's have a look at what that looks like over here, and we can see that it actually says float. It's telling us that the type of the variable B is float, which is correct, because you can see here that we assigned to be the 7.0, and of course 7.0 is a float. Now we can see from this particular runtime that in fact A was of type int, where int means integer, it's an abbreviation for integer, and B was of type float. But you'll also notice in the output we have the word class appearing. Now I'll come on to discuss what that means a little bit later in this particular video. But let's have a look at another example of a variable in Python. If we have a look at this particular program, here you can see that A has been assigned 3 plus 4j. Now you will have noticed from the previous video that this is an example of a complex number. And of course what we're going to do is on this line print its type. So let's see what we get. Well, you can see that it tells us it's of type complex, which is what we should really be expecting, because it's clear that A has been assigned a complex number. If we have a look here, we can see on this occasion that A has been assigned the string spam spam spam, and then of course the next line prints the type of A. And if we have a look over here, we can see that it actually tells us that it's an str. Now str is an abbreviation for string. So we can see from these three programs here, we have variables that can be integers, floats, complex, and string. Let's consider this program. On the first line you can see that it says A is assigned, and then you can see we have numbers 1 through to 6, all separated by a comma, all enclosed by these square brackets here. And on the next line we're going to print the type of A, and when we do that we can see we'll get this output here, and it's telling us that it's of type list. Now I'm not going to discuss what a list is at this particular point in the playlist, but they are very important data structures inside Python, and we'll be coming back to them in due course. If we have a look at the next program, well, the first thing you might see is it almost looks the same. On this occasion we're assigning to A, again 1 through to 6, all separated by commas, but if you look here you can see that the shape of the brackets have changed, and we often call these braces. They're a bit more curly than the square brackets. If we have a look at the output from this particular program, you get this, and you can see that A is of type set, and again we'll come back to look at sets a little bit later in the playlist. If we look here, I've made another slight alteration to the program, and on this occasion you can see we have this shape of brackets appearing, and when we print out the type of A, you can see we get something of this class of tuple. So the data type of A is in fact a tuple. So these square brackets here are used to define a list, these braces here are used to define a set, and these brackets are used to define a tuple. So whenever you use the type function, you can always find out what an individual data type is within your program by passing it in the name of the actual variable. And we've seen floats, integers, and of course we've now seen a list, a set, and a tuple as examples of types in Python. Let's consider this program for a moment. Here you can see A has been assigned 5, where 5 is clearly an integer. And on this line, what we're going to do is to print the value of the variable A. And the next line, we're going to print the type of the variable. So let's have a look at what happens when this actually executes. We get this. The value of the variable A is 5, as we expected, and the type of the variable A, we can see here it's telling us it's of type int. Now if we consider this assignment statement and reflect it onto an execution space that we dealt with very early in the playlist on Python, what's going to happen when this particular statement executes is we're going to have an execution space, and you can think of this kind of representing the computer's memory. And what will happen, we will get two things created. And this representation here is just a model, but it's a useful model for us to get a handle as to what's happening when an assignment statement takes place. What we will get the variable name, as you can see here. And this over here is an object which is also referred to as an instance of the int class, of the integer class. And this is the value stored in this particular object. Now this arrow represents the identification that points to the actual object. So what we will have is the ID, which is the object reference, and the object are bound together, as you can see here. Now A is in fact an instance of an integer class, and the relationship between the name and the object, well, we have the relationship represented by an ID. Now in Python there is a function called ID which we're going to have a look at next in the video series. But this representation here will help explain why when we see the type return the word class appears. Because we can think of class and type as being synonymous with one another, more or less the same. Now I say more or less the same because I don't want to tie them down as being exactly the same, because it means different things, frankly, to different people. But in Python, what you have to realize is when you say A is assigned 5, you're going to get an object which is an instance of the integer class. Now let's go on to another program that will produce something very similar to this diagram to explain what's going on. And here it is here. Here you can see I've got A is assigned 9.81. Now obviously 9.81 is a float. So in this case A will have the data type of float. So if I run the program, what we can see is the program is telling us that the value of the variable A is 9.8, because you can see here I was asking to print the variable A. But it also tells us that the type of the variable A is, and here you can see float, and that's because we've used this function here on A. But look very closely at this and you can see here it has the word class. So what this is really telling us is that A is an instance of the class float. But for the time being you're quite okay to say, right, well this is the type float, isn't it? Which it is. But you have to realize that it's an instance of the class float. So let's have a look at this. Here's A, this time being assigned 9.81, which is clearly an example of a float. This is the execution space here, and what will happen in this execution space, and remember this is just a model, you'll have this kind of relationship taking place. You'll have A having a name, you'll have the arrow which is going to be a reference to where the object is. This here is an instance of the float class, i.e. an object, and in the center of that we have the value, and we can see that the ID points to the object. So these two are going to be bound together, So the ID, the object reference, and the object are bound together. But what we have here, we essentially have two things. We have the name A with that arrow in it, which is a rectangular shape, as you can see, and we have an object which I've shown as a circle, and in the middle of the object you can see we have the value, and obviously that's the value that's assigned to A. Let's have a look at another example here. On this particular program you can see that A has been assigned, and in the square brackets we have 12, 25, 43, 65 and 78, and the two print statements are going to print what the value of A is, and they're also going to tell us the type of the variable A. So when the program executes, it does this. It tells us that the value of A is this, which we can clearly see is the case from the program. But if we have a look at the type, you can see here it says it's of class list, of type list. But if we have a look at this modeled onto this diagram here, there we have A being assigned the list. If we have a look at the execution space, we can see that two things will be created, the rectangular shape and the circular shape, and we can see that A is the name. There's an arrow inside the name, but over here we can see in this circle that in the center we have the value, and this circle is the object instance of the list class. And just to repeat, the arrow is the representation of the ID that points to the object in the execution space, and of course the arrow and the object are bound together, i.e. the ID, the object reference and the object are bound together in the way represented by this line here. So we can see that when we assign to a list, an object is created, and in the center of that object we can see the list. But the variable that has the name A has stored within it a reference to that object. But what you're really seeing in front of you here is the variable A. You see, the variable A really has two things. It has this region that is the reference that points to the object, and in this case the object is the instance of the list class. Let's have a look at another example. In this case you can see A has been assigned, and you can see it's been assigned 16, 22, 67 and 71, but look at the brackets. You can see the brackets are different than the last example. So when this program executes, obviously we'll get the output of the two print statements as shown here, and you can see it says the value of the variable A is, and you can see it outputs 16, 22, 67, 71, which is clearly what A was assigned to here in the code. But if we have a look at what the output is here, you can see that it tells us that it's of type tuple, or more to the point, class tuple. Now the reason for that is, of course, we've used this function here, type A, so it returns the type of A. Before we finish with this video, I'd like to leave you with a kind of feel for what a class and an object is and the relationship between them. So I'm going to represent a class by this particular squarish shape here. And what we have to realize is that a class is a template that defines the object. And a kind of rough description of this would be, if you're going to build a house, you don't just get the builders in and start laying bricks anywhere. What you do, you have a blueprint, and you follow the blueprint that's produced by the architect that instructs the builders what they're to do next, where the walls are to go, where the foundations should be laid and so on, and where the windows go and that kind of thing. But here in programming terms, if I have a class, inside that class it's going to have attributes and it's going to have behaviors. But I don't use the class directly. What I do, I say, right, well, you're capable of defining what I want my program to do, and to get those things done, I'm going to create an instance of you. So when we look at the execution space, what in fact will happen is we'll have an object created from this class. So it's rather like the house being built from the template, the blueprint that the architect gave. So we can see that the object is derived from the class. And now I can use the object. The object becomes, if you like, the execution bit that enables my program to do things. Let's look at this in a little bit more detail. Here you can see I've got the class again with a little bit more detail. And we can see it has a name, it has attributes, and it has behaviors. Now you've seen lots of names of classes already. An integer, a float, a string, a set. These are all examples of classes. Now they will have attributes and they will have behaviors. Now I'm going to come back to what an attribute and what behaviors are in later videos. But another word for behaviors, for example, is methods. So a method might, for example, calculate how much tax you pay on your salary. That's an illustration of the kind of thing a program might want to do, and you would call that the behavior of a class. But if you wanted that to take place, you have to create an instance of this class, an object. So the execution space is here, and what will happen is we will produce an object that this class defines. And you can see that I like to think of my objects as being circular, and in the center we have the attributes, and surrounding the center we have the behaviors, which we can talk of as being methods. But we're going to come back to this in later videos. But the reason I've covered this here is because when we're talking about types and you use the type function, you'll see that it puts the word class there. So it'll say class and then it'll follow that with float. So if you're wondering why it puts the word class there and not the word type, well, you can use type and class synonymous at the moment, more or less the same thing. But I think it's important that you realize that the word class is there, because all of these things that you create in code, when you say A is assigned something, that A is going to be of a certain type, which means it's going to be an object of a particular class. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and get an automatic update every time I upload a new video. Also consider subscribing to the Google Plus circle that relates to these videos.